So aside from like climatological forecasting, trend forecasting, and persistence forecasting and that sort of thing, these next few slides might kind of give you a hint of how complicated these sort of models must be in order to forecast for numerical weather forecasting. So, for instance, we talked about synoptic maps, and that we looked at a surface map, and these isobaric maps. Now we take them at different pressures. The way isobaric maps, for instance, work, remember, is they give you iso heights at a particular pressure. So an 850 millibar isobaric map would be iso heights that are closer to the Earth than, say, here in a minute we're going to see a 200 millibar isobaric map, would be basically at very upper elevations. So, so things that happen at upper elevations we've already talked about in this class actually have an impact on the weather we're experiencing. We talked about those upper winds. They tend to flow from the west to the east at upper elevations. And that flow can be straight, we call zonal, and that flow can have waves to it, we call meridional. And if it's wavy, it has ridges. It has ridges and troughs. Ridges and troughs if it's wavy. Ridges and troughs. All right. So these would be examples of synoptic maps, and this one is showing you. I don't know. You probably can't see it very well, but it is in your textbook. Notice that these are isotherms. The little they're two isopleths. The little ... those are isotherms, and then the other ones are iso heights. So this is an 850 millibar isobaric map. This one is showing you, well, it's similar. It's also 850 millibars isobaric map, and it also has, but we don't have the iso heights drawn on there. Simply the isotherms. Okay. So this is all just showing you 850 millibar isobaric maps. Now this is 500 millibar isobaric map, and notice that we have, in addition to the iso heights, we have wind speed and wind direction. So 500 millibar isobaric map must be upper elevations relative to the 850 millibar isobaric map. So we basically are looking at kind of layers of the Earth's atmosphere. Like this slide says, it's at this layer of the Earth's atmosphere you might start to look for how your mid-latitude cyclones are going to be kind of steered across the country. And then we go up to a 200 millibar isobaric map, and this is the highest one I'm going to show you. And you might see those colors there. Those colors there are indicating that ribbon of especially fast-moving air known as one of the two jet streams, the polar jet stream. So, yeah, the isopleths here, again, are iso heights to get to a barometric pressure of 200 millibars. So the jet stream you saw in pink just a minute ago, actually, in general, if we have a strong jet stream, we know it has, generally speaking, certain effects on, for instance, our thunderstorms. A strong jet stream, we tend to have more thunderstorms, and we'll have fewer hurricanes. And so if you're kind of thinking ahead, you're probably right. If the jet stream tends to be kind of weak, then our thunderstorms will be weak in general, and they'll move slowly, and our hurricanes will be strengthened. So this is showing you kind of looking at looking at the Rossby waves, looking at upper elevation, and things moving across from day to day, February 1st, 2nd, 3rd, and 4th. So we can anticipate then the system as it moves across the country.